Thanks, Christina. Thanks, Meredith. Great to see familiar faces on this Zoom call. IARPIC I have presented to in the past, but have gotten most of my updates from Christina recently, but it's nice to be invited back to present some of our latest synthesis work. And I'm going to be talking about a paper where at least a few of the folks on this call are co-authors of that. And it's really synthesizing a lot of the work that was done through the Permafrost Carbon Network. So many of you have contributed to that network, both in data, paper writing, ideas, and just helping move the whole thing forward. And so I'm going to try to give you a little bit of a snapshot of a new paper that's coming out actually on Monday of next week. I think I have maybe a 15 or 20, or maybe just like 15-minute presentation, but hoping to answer kind of questions as well. So if you think of questions during what I'm talking about, feel free to put them in the chat, and then we have time after my slides to just have a roundtable discussion. So with that, let me go ahead and share the slides that I have. I think I'm sharing the whole deck here. Let me get this into single. Can someone confirm to me that they are? Okay, thanks, Christina. In the world of Zoom, we've all mastered multitasking, but it's still sometimes a challenge to make sure you are doing the right thing. So the title that I have for this talk is the title of the paper, Permafrost and Climate Change, Global Carbon Cycle Feedbacks from the Warming Arctic. Like Christina mentioned, I've been working on this topic for a couple of decades. I am at Northern Arizona University as a professor. Also have worked closely and am affiliate with University of Alaska in Fairbanks, where I do a lot of field research. Today, I'm going to really be talking about the synthesis science part, trying to bring together information from individual studies to understand how the warming Arctic might impact future climate. Okay, I've mentioned this already, but the paper in question is coming out in the Annual Review of Environment and Resources. So it has this title. The authors are here and the citation is below. And for me, it's an important paper because I've been doing synthesis science on this topic for over a decade, as Christina mentioned. We've been leading the Permafrost Carbon Network for that long. And I feel like this paper actually is a new advance over some of the syntheses that we published in the past. So I have a hope that this paper, the ARER, as it's known for short, will be the new best cited paper for future carbon emissions from a warming Arctic. I'm going to show you just some of the highlights and go to kind of the findings at the very end that talk about what's brand new about this paper. So the overall topic that we're thinking about is the fact that the Arctic stores a lot of carbon, organic material frozen in permafrost soils. And this region has such a large amount of carbon that it is potential feedback to climate. So we think about a warming Earth and the warming Arctic, thawing permafrost, and this organic matter is now subject to decomposition. And so this is a wonderful illustration from our graphic artist Victor Leszek, kind of showing you how this thawing permafrost on the right-hand side puts this organic matter into contact with microbes that can release it both as carbon dioxide or as methane if that organic matter ends up in lakes and wetlands. The mammoth here, of course, doesn't represent the current Arctic, but it's the idea that this organic matter has been trapped for hundreds or thousands of years in permafrost. And now that the climate's changing, we're kind of destabilizing this old carbon, putting it up into the atmosphere. And these greenhouse gas emissions then have the potential to accelerate human-induced climate change. So the Permafrost Carbon Network has focused on this science question that's written here. What's the magnitude, the timing, and the form of permafrost carbon release to the atmosphere in a warmer world? So if we know the Arctic's warming from measurements, what we want to know is how big this feedback to climate change will be. And so how much of the carbon that's frozen will enter the atmosphere? Is that going to happen over years or decades or centuries even? And then this release of CO2 and methane, these two greenhouse gases, have this different impact on climate change. And so knowing the form of carbon release is critical. It's easy to articulate this question, and we actually can measure it at the site level, but we need to know it at the scale of the entire Arctic to understand the climate implications. So with that as a backdrop, what this paper is doing is laying out a number of scenarios of a future world. And so I show here this picture of a satellite photo of the Earth down in the lower right. As seen from space, here's the Earth, it's the one we live on. Going out into the future, of course, there's more than one world. There's 9 possible worlds shown here because we haven't got to the future yet. And of course, where we end up depends on what we do as humans in terms of our own greenhouse gas emissions, and then how the Earth's carbon cycle responds to that. And so this paper is thinking about these possible worlds we might end up in and what that would look like in terms of Arctic carbon emissions. I'm going to show you the sort of estimates that we came up with. And what you should know is that we took all of the peer-reviewed literature across a wide range of studies to come up with these emission estimates. So these estimates are a synthesis of many studies that are in the literature and many different kinds of studies. And so we tried to range our synthesis efforts to include Earth system models, climate models, but we're also thinking about ecosystem models and box models, and we're also thinking about laboratory experiments and field measurements. And by encompassing this wider range of estimates, we feel like these future worlds that I'm going to show you today actually encompass a much broader range of the literature than has shown up in past syntheses. And so the first thing I wanted to kind of show you with this graphic, I'm going to kind of build this graphic up to its final form, but it's representing the cumulative carbon emissions in the form of carbon dioxide on the x-axis. Let me see if I can get a little pen going here. Yeah, here we go. So here we have cumulative carbon dioxide, and then we have cumulative methane over here. So these 2 greenhouse gases, and we're measuring that cumulative amount in this century. So by the year 2100, we'll have released these amount of gases, and we're measuring this in billions of tons of carbon. So we call that a petagram, 10 to the 15th grams. That's the measurement and these numbers on these 2 scales. The thing maybe to notice in this version of the graph is that carbon dioxide, the numbers are a lot larger. So in terms of the organic matter frozen in permafrost, a lot more of it will come out in the form of carbon dioxide. So these numbers are bigger than the methane numbers, but methane has a stronger impact once it's in a climate. It's got a greater radiative forcing. So you'll see this graph unfold, and the relative effect of methane will become more important as compared to its weight alone. So that's what we're looking at, cumulative greenhouse gas emissions. These 9 future worlds, which one we end up in is going to depend on climate change, and the path of that climate change is really set by people. So that's the first key take-home point, is the Earth's climate is changing because of human greenhouse gas emissions. So fossil fuel emissions, coal, oil, gas are being burned, and how much of those fossil fuels we burn and put in the atmosphere will determine what our future climate looks like, and then determine what comes out of the Arctic. And so probably most people on this call know or have heard of these RCPs, representative concentration pathways. These are scenarios talking about future human emissions. Now, in the latest IPCC and Earth system model runs we call these now SSPs, shared socioeconomic pathways, but they're essentially similar, looking at the radiative forcing from different scenarios of human development. The ones that I show you here, I used RCP because the literature that predicted Arctic carbon really were based on this older set of RCPs, but they're kind of equivalent to SSPs, excuse me. But just to put these into context of things you hear about, the RCP 2.6 that you might know as keeping global warming to less than 2 degrees. So we hear that in reference to the Paris Accord. That's the ambition that nations around the world have, is to avoid dangerous climate change. We would have to follow an emissions pathway that looks like RCP 2.6. A mid-range warming, so if the global warming by the year 2100 got to 2 or 3 degrees C, so we've exceeded our 2-degree threshold. That's kind of a mid-range warming. I put the Inflation Reduction Act here because in the US, we just passed legislation to decrease our own emissions from 2019 levels. And if the whole world did that at that sort of rate, which is kind of a big if, we would hit a warming of between 2 and 3 degrees by 2100. And so nationally, that's an important first step, but it's only one step if we really want to get to keeping the global climate below 2. And then we have something called RCP 8.5, which is if we don't have climate policies and we kind of keep burning fossil fuels, we'll end up between 3 and 5 degrees warmer, again, globally. And so the Arctic would be anywhere between 2 and 4 times that by the end of the century. And you can see I put these RCPs along the axes because how much carbon, CO2, and how much methane comes out of the Arctic depends on how much human warming exists. So let me give you an example of that. I'll just move forward. And this is an example scenario of kind of a mid-range release of both carbon dioxide here and methane. And so you'd end up in a world shown by this pie. And the pie is illustrating kind of the climate forcing coming from CO2 and methane. So even though the number of methane is a little bit less than 3 compared to 75, the methane would be about 1/3 of the overall warming coming from the Arctic under that scenario. The number 117 is the weighted value of those two scenarios. So we get this number of 117 out of this particular scenario that I'm showing here. So that's one scenario, kind of this mid-range CO2 release, mid-range methane, and you can kind of tie it back to like maybe this is our mid-range human warming scenario on both of these axes. Now, we can expand this from one potential future world to many. So I guess I said this already, that the climate impact is both from carbon dioxide and from methane. But we can actually extend this to sort of an envelope of possible worlds. So here are 9 future worlds, and the 9 worlds come from 3 levels of CO2. So you could have low CO2 emissions, medium CO2, or high CO2. And then you can also do the same of having low methane, mid methane, and high. And so these 3 CO2 and 3 methane emissions combine to give you 9 future worlds. So these 9 future worlds have a cumulative amount of carbon coming out, a particular climate impact. And that climate impact is the response both of, it's the response of the Arctic, but it's set by the climate change from human emissions, plus the response of Arctic ecosystems to land to change. So all those things we hear about, including tipping points and fires and all the sort of ecosystem dynamics that control how much carbon goes from the ecosystems into the atmosphere. So let's think about these numbers that I'm showing you here, these cumulative carbon emissions. Like, what do these actually mean? And so this graphic is not looking at the Arctic, it's looking at fossil fuel emissions from different countries. When we think about the Paris Climate Accord or the Inflation Reduction Act, we're thinking about nations trying to reduce national level emissions. So our main policies are directed to national levels, trying to reduce our own emissions. The map shows the present day fossil fuel emissions kind of sized by country, but this legend over here shows you the cumulative emissions that have come from different countries, both in the past, that's on the historical side here. So this is how much carbon has been released from 1850 to the present. And then there's the future. There's emissions that will happen this century. And of course, these are only numbers for one scenario. Nations are trying to, of course, reduce these emissions. So we could hope that these numbers will decline, but they'll just give you some kind of estimate of carbon that's already been released by nations and carbon that might be released in the future from fossil fuels, primarily, a little bit from land use change. So let's put those two concepts together. We have carbon coming out of the Arctic over here. We have these national emissions, and I titled this the country of permafrost emissions, because you can imagine that the Arctic nations have the permafrost carbon, but there's no policies that are being set to reduce these permafrost carbon emissions. So it's kind of like unregulated emissions coming out of this country of permafrost. And the main point of it is you can see these scenarios. Here's the one right in the middle, 117 billion tons. It's like an entire nation of emissions, but it's not represented here. And so it's this extra sort of unregulated carbon that we think needs to be accounted for when we think about total climate change. It's not only the emissions coming from nations in terms of their fossil fuel use, but it's these additional feedbacks from the warming Arctic. Okay, so that is kind of the figure that shows up in the paper, and this is kind of described in more depth in the paper of how we get to it. But essentially, this envelope of estimates are all represented in the peer-reviewed literature. So we have solid evidence from papers that kind of supports all possible ends of these emissions estimates, depending again on both what humans do in terms of our own emissions and then how these ecosystems respond in the future. Okay, so I guess I painted a picture. This is a photograph near my field site in Denali National Park. It's kind of apropos to the conversation. There's kind of dark clouds gathering on the horizon as part of thinking about this feedback out of the Arctic to climate change. I think it's important to take the discussion towards, what kind of solutions might there be for these extra Arctic carbon emissions. And the first one I think about at the global scale is just reducing overall human emissions. And so this is a graphic from the SROC, the IPCC report that Christina mentioned. It looks at permafrost in the past, and it thinks about how much permafrost there will be in the future up to the year 2100 based on these same RCP scenarios. And the main point of it is that, if we reduce human emissions, we save permafrost. Now, in all of the scenarios, we don't have as much permafrost as we did in the past, but if we limit global warming to less than 2 degrees, we have a lot more than if we don't. So human carbon emissions at that global scale, that matters for the future of permafrost. And so maybe it's the first idea of hope is that if we reduce human emissions, we keep things below 2 degrees, we save permafrost, we would have, oops, let me get that back. By 2050, we would have 33% more permafrost if we had slowed our warmings than if compared to if we didn't. And then all the way out at the end of the century, we'd have 145% more permafrost remaining if we had these policies to limit warming than if we didn't. So we can do something at the global scale. Myself as a scientist, I think about, okay, beyond limiting total human emissions, what is it that I can do or scientists can do? This is a photo of myself at the same field site. I'm looking at an eddy covariance tower that's measuring the exchange of carbon dioxide and methane with these sensors. And so we track the movement of carbon in and out of these ecosystems. This is a site that I've worked at for a couple decades. I call it the Arctic Carbon and Climate Observatory, ACCLIMATE. And here we are kind of detecting this exchange and movement of carbon. At this particular site, there's carbon already being released from the permafrost into the atmosphere. We can measure that quantity. And the key question at sort of the scale of the whole Arctic is that not only is how this site is changing, but how all the sites are responding to warming. And so myself and many others that operate these sites are linking together in a network to try to understand the total emissions of carbon at the Arctic scale. So you can think about a network like this not as something that is changing the emissions of carbon out of the Arctic, but it's more of an early warning system. It's very similar to what you might think about for hurricanes. Like, we can't change the path of hurricanes, we can't change their intensity, but there's a huge societal benefit for knowing where hurricanes are going and being able to forecast that. So in the same way, we may not be able to change the Arctic carbon emissions, but by knowing sort of in quasi real time how much carbon is being released helps us tune our societal policies better to take this extra Arctic carbon into account. So as a scientist, I'm working with others on this call, maybe everyone, thinking about how we can build this kind of Arctic observation system and really bring benefit to society, knowing how much extra carbon is coming out of the Arctic. Okay, so let me just show you a couple of final bullet points and then open it to discussion. In the past, I used to call these sound bites, but maybe memes is the newest word for this type of thing. Here's a meme that I hear a lot in the news coming out of past work. We used to say that the permafrost carbon pool was twice the amount of carbon that was in the atmosphere. The paper that I am talking about today moves this number to 3 times. And it's based on the surface number, this 1440 to 1600. This is the twice 2x the atmosphere, but we've been able to quantify this extra atmosphere's worth of carbon in places that are in deep soils outside of the Gedama region, and then also under the ocean where permafrost still exists. So that's one new soundbite coming out of this paper. If you translate that carbon in the Arctic to other places, the permafrost region contains 50% of the soil carbon found in all other Earth's biomes, in only 15% of this global soil area. And this is likely a minimum. So there's a large amount in the Arctic, and it's a disproportionate proportion based on our area. This is the country of permafrost emissions I showed you already. We could add an extra 55 to 230 billion tons of carbon into the atmosphere as the Earth warms. And we really need to account for this in order to meet temperature targets. So if countries are trying to reduce fossil fuel emissions to keep global warming below 2 degrees, we also have to account for this extra amount coming out of the Arctic. The AR6 published by the IPCC just last year did try to account for some of these extra permafrost carbon emissions. Our estimates here go even higher than those. I think that the IPCC AR6 was a little bit conservative in its approach. So I guess this publication is saying there's even more carbon that we need to be counting if we want to hit the right temperature targets. This is something that's not in the paper, but is based on my own calculation. If we're thinking about what's coming out of the Arctic, these extra emissions, they accelerate climate change. So they're adding about 10 to 15% more carbon than is already coming out from fossil fuels. So fossil fuels are still the dominant driver. But if you put that 10 to 15% into context, it's potentially decreasing the land carbon sink by 33 to 50%. So already the land is absorbing some human emissions, and we're essentially saying that the Arctic could wipe out half of that benefit. So that's pretty significant feedback response from the warming Arctic. And then the final point on my slide is back to that idea of slowing down global climate change slows down Arctic climate change, and then it just is keeping us away from potential Arctic carbon cycle surprises. We know about threshold events, we know about tipping points, we know about processes like abrupt thaw. The slower we warm the Earth, the further away we stay from these, I think, nasty surprises that could be out there. This has gone into a little bit more in detail in the paper, but I'll just leave it with that little soundbite. So that's the end of my slides. And Christina and Meredith, I just wanted to open it up back to the group. And I don't know if you want me to stop share or leave this set of points up there when I do that.
Maybe leave it open in case questions arise around the slides. Yeah. Thank you, Ted, for the presentation. That was really great. I see Vladimir's hand raised. Vladimir, do you want to ask your question?
Yeah, Ted, great update. Great. Thank you very much. I have only kind of, it could be a formal question, but why are you talking about 9 scenarios? It's really only 3. I mean, on your, this very nicely set diagram, you have 9 globes, but really it's all what kind of scenario of emission, future emission will be realized. And it's only 3, 2.5, 4.5, and 8.5. So it's diagonal. And all other things, why do you still consider differences in methane release and CO2 release, which if you assume one of those scenarios, that will be your diagonal.
Yeah,
that's all 9 things.
Yeah, that's a good point. And the reason for that, why you have 9 instead of 3 is that the 9 worlds are defined by the climate change path set by people and the response of the Arctic system. And so the y-axis with methane, at least based on the literature, is more clear. Like, look, here's low warming, here's mid warming, here's high warming. And the more warming you get, the more methane. So that's kind of the 3. Carbon dioxide turns out to be more complicated, and it's shown by these like wider bars here. And the reason CO2 is more complicated is that you can emit CO2 out of soil, but you can also take up CO2 by greening vegetation. So plants taking up more can actually offset. And unfortunately, the state of the science is that we get both. So you could imagine more warming releasing a lot of carbon, but you could also imagine more warming stimulating plants that the CO2 gets drawn down. And that's why you end up not with this like diagonal, but you actually end up with this more complex, 9 scenarios. And I hope that defines it. It's the response of the Arctic system that we unfortunately just still to date don't know whether or how much the plants are going to offset on the CO2.
So that's what you're showing is not just release because of the permafrost, but the net kind of net effect of.
Yes, it's how much net ends up in the atmosphere. Okay. But that's a balance. I didn't really go into the carbon cycle, but that's a balance of release minus the uptake.
Okay.
So this is like the extra that ends up in the atmosphere after you've had both release and uptake happen. And there's support in our best models, will do both of these things. Like we end up in all of these points. We can't get rid of any of them and say they're not plausible. The reason why I say that this is more sophisticated than the IPCC is that they give you sort of a mean number with a standard deviation. But I think that shows like a little bit too much certainty of the issue. And I think this is actually a better way to think about it.
Thank you.
Peter, do you want to ask you a question?
Yeah, sure. Thank you. Ted, great talk. And I really appreciate the way you built the logic there and put that figure together. I wish more people would do that. But I did want to ask what your view is on the RCP 8.5, which I think, and Art can correct me if I'm wrong, but the actual emissions are still tracking more in somewhere in the 4.5 zone, and 8.5 is an emission scenario that so far we're not on. And
yeah, people get a little excited about these things. I mean, we're not on 4.5 either. We're more like on 6, but a lot of these thresholds will pass in the next 10 or 20 years. So
yeah,
the scenarios, if you track them back, they don't look that different in present day. It's just the big questions are like, in 2030, are we heading down? And you're heading down in terms of our net emissions. And our nation has been done, but globally, we're not doing this. And so a lot of it has to do with these pledges made by developing nations, like what they're thinking they're going to do between 2030 and 2050. And so it's just too premature to say, like, are we on RCP? Well, you mentioned 4.5, but we're above that. We're closer to one called 6 that I didn't show you.
yeah.
And people say, like, oh, we're not on 8, but we'll know by like 2050 which one we went on. And the important thing, the reason why we use this wide envelope is that you kind of want to look at not outliers, but you want to look at high values, intermediate values, and low values. That way, no matter where the world goes, you've kind of done the right scenarios. So maybe your point was like RCP 8.5 is a little bit high, but we want that outer bound. We don't want to.
We do want to run the models at that 8.5. I agree, but sometimes people can, particularly outside of our, or even inside our community, can sort of spiral into doom if they think we're actually committed to 8.5, which.
Yeah, that's right. And I think we're not committed. By the year 2030, we very quickly know if we're going to get to like 1.5. So we're very quickly going to have an answer on, is that possible? I think by 2 degrees warming, we know by like 2040 or 2050. I mean, to get to 2, you have to have net zero emissions for the world. And so we'll know by then if we're anywhere close to 2. Yeah. But that's a whole discussion itself. I see lots of other hands, but hopefully I answered your comment there.
Yeah, no, really nice work. Thank you.
Next question by John.
Hi, Ted. Great presentation. Thanks. I have a quick question about your AWARE network for the PCN. I was wondering how realized that data network is in terms of climate and other factors that are being put into it.
Can you elaborate? What do you mean by climate? Sorry.
So you have the Arctic Carbon Warming Network AWARE on slide 14, and you said this was a network of towers that have been working in permafrost regions. And I was wondering, is that an accessible network? Can we download data from it? Is there... what's the state of the AWARE network?
Yeah, what is the state? And there's other people on this call, like Brendan and the Permafrost Pathways project, that are trying to expand this. But those points that I showed in 14 actually are existing sites. They extend beyond just tower sites, but they're carbon flux sites that either have operated in the past or exist today. And there's a couple issues, as not all of them are continuously monitoring systems. So it probably looks better than it is, but that's part of the current work of, PCN, Permafrost Pathways, and other groups, is trying to both expand physically the number of sites that are there. And then the other really timely topic we're trying to push forward on is trying to get these data more readily available to science and policy, like more up to date. And so that's in particular one focus of the Permafrost Carbon Network. So it's not a perfect network by any means. These are all essentially individual sites operating on their own budgets in their own countries, trying to keep things together. But that's part of what we think of, a value added as scientists, is trying to bring this together as an actual functioning network. One problem with sort of permafrost being below ground is we don't have the analogy of sea ice where we can take a snapshot with a satellite and tell like the total extent of permafrost, partly because of limitations to remote sensing. But between remote sensing scaling tools and ground-based measurements of carbon fluxes, that's probably the best way to keep ourselves aware of what the carbon emissions are.
Great, thank you.
And maybe Brendan had his hand up, and he also is involved in a big project to help make this network better. So you can either put in a plug, Brendan, or ask a question, or both.
Go ahead.
Maybe I'll do a little bit of both. Yeah, thanks, Ted. So yeah, I mean, Ted mentioned this Permafrost Pathways project. We've been working with Ted on this actually for a number of years. When was that first workshop we had in Santa Barbara? Was that 2018? And I know you all have been thinking about this for longer than that. And so, as Ted mentioned, it's not a perfect network. We are as a group trying to move it forward and make it better. And so, part of it is recognizing that we need sort of some sites we need to sort of like have more year-round coverage, or maybe sites have CO2 but not methane. And so that's something through Permafrost Pathways we're trying to actively help. And we're also trying to establish sites in new regions that are what we call critically undersampled, basically types of environments across the Arctic that we don't have any data currently. But we've also been working with Ted and team to sort of aggregate all the data that do exist. And so it's not a perfect database, but early this year, we published a database called ABC Flux, Arctic Boreal CO2 Flux, which takes a lot of these measurements and standardizes them and puts them into a monthly format so that modelers or, data synthesis scientists, whoever can use it. And then, I don't, Ted, if something you wanted to talk about, but, we're also, and this is really your group, but like trying to work towards methods by which researchers could be sort of posting and showing their data in a bit more of a real-time or near real-time format. And so these are all things that we're collectively working on, and I think we're making some real progress, but it's hard because, as Ted mentioned, a lot of these sites were established by different researchers with different funding mechanisms in different years and different countries of the Arctic, and there's often a pretty big lag in terms of when the data gets processed and put out there, but we're trying to improve it towards this vision of what's what's happening across the Arctic, the permafrost zone now. I had like two kind of technical questions. Great presentation, Ted. I'm really really looking forward to reading the paper when it comes out early next week, and I think it's great timing. I guess I was just curious, like I guess the first question would be, what kind of assumptions did you have to make when you sort of mash these different studies together? You mentioned like field studies and laboratory experiments and modeling studies, especially ones that don't necessarily, simulate both CO2 and methane. And I was also curious how many of them, and I think the answer is probably not many, but how many of them included abrupt disturbances like wildfire or thermokarst processes? And then, if they didn't, or like, what's your take on how those sort of nonlinear abrupt disturbances might change the numbers or change the story?
Yeah, and I didn't go a little bit into the detail of like how we came up with the scenarios. And this is kind of like reverse engineering, is we've done all these syntheses we've done MIPS, which are modeling intercomparisons. We have box models that do abrupt thaw. There's fire emission estimates in different papers. This high, medium, low actually just are very simple kind of like increases in CO2 release and methane release, like per year increases, kind of linear increases. And then we sort of did them at these three levels of low, medium, high, low, medium, high. And then we kind of went back and looked at all these different papers and said, do they fall within this space? And so it really does encompass like fire emissions papers and abrupt thaw models and earth system models doing permafrost. And, I'd like to, and actually it's sort of a question I have back to the community, or a challenge is like, find me a paper that falls like outside of this, because at least based on our study, we can find papers in all quadrants of that. And this is back to what Vladimir says, is we can't rule out any corner of that. We can't rule out any of these 9 ones. My paper that's coming out on Monday talks about a few black swans. So there's even some scenarios that do fall outside of these 9 scenarios, and we kind of go through like what those would be. People haven't written papers saying like, hey, we really think the Arctic is going to green so much that we're going to take up more carbon than was ever released. But there are even a few kind of scenarios that we know of mechanistically that fall outside. But otherwise, I would like to think that these 9 sectors kind of represent most studies that are out there. But, you know, it'll be a challenge to the community. Someone might send me a paper saying like, hey, no, I have one that's different. But right now, this, I would say, in our decade of synthesis, they kind of fall under this umbrella of these 9 scenarios. But the scenarios themselves are not mechanistic in any way. They just get to do these like cumulative levels that are consistent with the literature. I saw Catherine with her hand up, and then Aditya after that. And I don't know if...
Thank you for your talk, Ted. Looking at your slide that you have up right now on the globe and where the global permafrost is, the greatest amount is in Russia. And I think, you know, all models are going to have lots of uncertainty in them. We've been talking about that. The geopolitical tensions can impact that uncertainty because we can't always get the data that we want, or we maybe perhaps can't rely on the data that we get from various nations. How do you work that uncertainty into your models? What do you do about, hey, maybe we can't get anything valid out of Russia, you know, for this 22 in the years to come?
I mean, that is like a super important question. And I mean, this graphic Brendan mentioned came out of a workshop. It's a little shiny tool that we did back in 2018. And we already felt like we were undersampled in terms of number of sites. And now, you know, as of February 2022, we just layered on geopolitics to this. So 2/3 of permafrost area is in Eurasia. 1/3 is in North America. We're missing a lot. We do have remote sensing that helps fill in the gaps. We right now are analyzing kind of this question of, if you don't have access to either data or sites in Russia, you know, can you find places with similar ecosystem and similar dynamics elsewhere that help you understand what's going on there? And the answer is, yeah, you can extrapolate some. You don't totally replace not having data or sites from that region, but you can kind of make an attempt to improve your situation by doing these kind of representative or gap analyses. But I think it comes back to climate change is this global issue, and it's a huge negative to all of us if we can't share data globally. We don't have enough measurements and observations and money to really understand the problem in its entirety unless we're doing this across national communities and boundaries. So geopolitics really is mattering in this case.
Thank you.
And I don't know, I know Aditya was next, and I don't know if Vladimir can say anything about the Russian situation before we go to Aditya.
Well, I had the question really, and not related to Russia, but
okay, sorry.
I was surprised. I was surprised that there's nothing from China, and I believe there's, you know, should be many towers there. How this could be solved, and it's I don't know if it's easier or more difficult compared to Russia, but at least at this moment, China could be a little bit more open than Russia.
Yeah, and that's right. And maybe this map actually could predate. I think we focused on sites that were above or in the Arctic and boreal regime, so it probably isn't showing China's data right here. So I think you're right that improvements are possible there, thinking about China being sort of the Qinghai Tibetan Plateau, which is permafrost, but outside of what we would call the northern circumpolar region, different ecosystem types, but some dynamics sharing.
Yeah, there could be some also in northwest, northeast of China as well.
Yeah,
could be. Yeah, and about Russia, of course, well, it's hard to say. Nobody knows what will happen, but we still have contacts, and we're still getting data from our permafrost temperature network, but we have no idea what will happen in the next few years.
So I'm going to interrupt real quick. We have 5 minutes left, and 2 more questions, I believe. And after that, I would say, or 1 more question. After that, maybe we can leave a couple minutes for a few updates and just like informational, some information for people that are of interest in regard to permafrost activities. So maybe Aditya, you can ask your question and then we'll move on.
Yeah, I'm audible, ma'am.
I couldn't hear that, but I can hear you. What did you say?
Yeah, just a minute. Yeah, I'm audible. Yeah, as Mr. Ted explained that all the things related to the emission of CO2 and methane. But I think, as per my concern, this is not only the issue of climate, but this is specifically issue of geopolitical issue, because this time, as we can see that the Russia and Ukraine, there is lots of problems, and the most of the permafrost region is under the Russia. And another part that there is no reason related to the China, but the emission capacity of China is more than other developing countries and developed countries. So this is a very confusing that the countries which are involved in the emission compared to other countries, but there is no involvement of the permafrost. So I think we can control, or we can limit the emission, or we can move to the zero emission with the help of politics, not only on some of research project, some of policies related to the Arctic nations, because it's not only the part of Arctic nations, this is part for the whole world. Because if Arctic region will damage, then we all will face such problems like early avalanche. Recently, we have faced the 2 and 3 avalanche in Himalaya region, because recently I have visited to Himalaya. So, in past few times, like Kedarnath tragedy in 2013, the similar region we faced the 2 avalanche within a week. So this is not only the reason that we are not part of the Arctic region, but it is the part that how much we are contributing to the environment. So the main focus to take the advice for all over the countries, like Asian countries, European countries, and Arctic nations like Russia and other regions. All of you know that what is the current situation between Russia and Ukraine. So this is a very important, first to collect and give the collective approach, not only on documents or some summits, but also the collaboration like geopolitics, uh, keep apart from other issues that we want this particular space, or we want to this particular boundaries. So first we need to collect with the geopolitical point of view, as per my concern.
Yeah,
Because
that's probably
India
a
is
good.
also,
Let me just answer that a little bit, because we're running out of time here. But I think it's an important point, and maybe my first one is that really kind of limiting global warming at the, with all nations will slow Arctic emissions, and maybe that's the point that Arctic carbon emissions affect the whole world, and so not just the nations that are in the Arctic. And maybe I'll just leave it at that point, and Christina, pass it back to you. I think there's just like a minute or two left, but if you want to wrap it up,
and people, thank you, Ted. People are leaving the call, and that's totally fine. So maybe we can just hear quickly from Jerry in regard to the next permafrost meeting that's happening in November. If you can give a 1-minute pitch for that meeting, that would be great.
Okay, well, great. I was just signing off, but thanks, Christina. So the next November 10th meeting is going to be about the U.S. Permafrost Association. Larry Hensman is going to kick it off, since he was one of the originators of the USPA back in the early 2010 zero. And then it'll be followed by our present president of the USPA, John Thornley, and Mike Lilly. and Anna Wagner will follow it up with a report on how we've supported students, many of whom are on this call over the years. So it's a history. It's the 20th anniversary of the USPA this year, and we're going to be trying to highlight some of the accomplishments and future directions. And then not only that, we'll be summarizing all the activities at AGU. We've just done the quick look at the program, and there's approximately 650 presentations at AGU related to permafrost and seasonal frozen ground, which we always address. So it's going to be a huge meeting. As you know, many of you have sessions and are presenting at our session on Friday afternoon. Hopefully people will hang in for Friday afternoon. And the kickoff, of course, is on Monday when there's a number of permafrost sessions and presentations. So the November session will kind of be a summary of the last 20 years and a look towards the future, including the AGU activities, which will include our annual social event on Tuesday night after the cryosphere reception or the presentations. So it's a very busy next 2 to 3 months, and hopefully, Christina, that covers what you wanted me to say.
Yes, that did. Thank you so much. I think we have hit the top of the hour, so I'm going to end this meeting. Thank you, Ted, again for your presentation, and I hope people have the link to read the full paper when it comes out on Monday. And then, as Meredith said, this webinar will be available on the IARPIC website if you want to go back and look at something. Thank you, everyone, and have a good rest of your day.
Thank you.
Thanks, Ted.